It has taken over 4 years and 3,000 nautical miles to get to this place in space history. The inaugural launch of a rocket from a sophisticated ocean-based launch platform. The 3-stage Sea Launch rocket will be launched from the Odyssey, a self-propelled, semi-submersible, 436-foot-long, 21-story tall launch platform. The rocket uses an environmentally friendly combination of kerosene and liquid oxygen to send its payload into a geosynchronous transfer orbit some 23,000 miles above the Earth.
We wanted to provide reliable, affordable access to space for our commercial customers.
An open ocean launch provides increased operational flexibility with virtually no restrictions on launch inclinations, which ultimately result in various Earth orbits in geographical coverage areas. The Sea Launch mission begins in Long Beach, California, at the spacecraft processing facility where the satellite is fueled and encapsulated. It's then moved to the command ship, where it's horizontally mated to the upper stage. After integrated testing, the fully integrated launch vehicle is then transferred from the command ship to the launch platform before both vessels depart for the equator. Upon arrival at the site, some 1,300 miles southeast of Hawaii, the launch platform is submerged to its ballast depth of approximately 70 feet. The assembly and command ship and the platform are then linked with a bridge on the second day. Both vessels operate dynamic positioning systems which, along with a global positioning system, determine and maintain precise coordinates of the launch pad and the command ship. The launch platform also has a stabilizing trim and heel system that maintains a level attitude within 1 degree in up to 3 meters of wave height. 24 hours before liftoff, the command ship pulls away from the launch platform for rollout and erection of the booster. The Odyssey crew transfers to the command ship, where the mission control team will direct the automated fueling process. 3,500 electrical circuits and 25 fluid lines are connected in just 2½ minutes. Propellant loading begins shortly thereafter. With 17 minutes remaining before ignition, the transporter erector is lowered away from the booster, returned to the hangar, and the hangar doors and roof are closed. The command ship is positioned safely about 3 miles away.
At T-minus 17 minutes, the erector moves away from the rocket, and we are essentially committed to launch or scrap. We are 17 minutes from defining moment of our project.
The 200-foot Sea Launch rocket will lift off from the equator. 10 seconds into flight, it performs its roll maneuver, which maximizes flight performance and places it into its proper trajectory. The Sea Launch first stage provides the thrust for approximately the first 2½ minutes of its journey. The second stage booster carries it for another 5 minutes. During that time, the payload fairing is jettisoned. At second stage separation, 4 solid propellant rocket motors, located at the base of the second stage, fire to back the stage away from the block DMSL. The block DMSL provides the final 4½ minutes of final burn to reach the initial ejection orbit. Then, approximately 1/2 of an orbit and 33 minutes later, the block DM performs the second and final burn, lasting slightly over 6 minutes, to achieve the desired payload geosynchronous transfer orbit, GTO. Depending on individual payload mission requirements, the block DMSL can perform additional burns as required by payload mission requirements. Separation of the spacecraft occurs at approximately 1 hour after liftoff. The block DMSL performs a contamination and collision avoidance maneuver, which prevents future contact with the spacecraft and vents all residual propellant and gases. Tracking and telemetry returns are provided by a special antenna on the assembly and command ship and TDRIS, the Tracking and Data Relay Satellite System. Existing Russian tracking ground stations complete the mission. The Sea Launch system will be used primarily for the delivery of commercial communications satellites into geosynchronous transfer orbit. These satellites are designed to deliver services such as direct-to-home television, internet access, distant learning applications, and improved data, voice, and video information capabilities. The ocean, the last great frontier on Earth and the site of untold mysteries. It is here, at 154 degrees west longitude on the equator, where the pioneers of today will use a combination of innovation and proven technology to journey into the final frontier, space.
You can't really compare it. This is like writing history. We are doing something quite unique, and it's sort of once-in-a-lifetime experience.
Captain Ordahl is referring to the world's first commercial rocket launch from a platform at sea. Atop this floating launch pad, a high-performance sea launch rocket will carry a simulated communications satellite into geosynchronous transfer orbit some 23,000 miles above the Earth. The idea of launching commercial spacecraft from a sea launch platform was first conceived in 1993. Shortly thereafter, the sea launch venture became a reality with 4 impressive international partners: Boeing Commercial Space Company, RSC Energia, KB Yuzhnoye PO Yuzhmash, and Kvarner Maritime. Their mission was simple: to place large commercial satellites into orbit from a location that provided maximum benefit to the customer.
By being able to go to the equator to launch, Sea Launch is going to be able to put satellites into orbit that are 10 to 15% heavier than what you can launch, say, with the equivalent rocket from Cape Canaveral. This means that the satellites can either carry additional payload in the form of the transponders or additional fuel that allows them to last longer, and this will translate directly to the bottom line for the satellite customer in terms of revenue.
The sea launch concept is no longer a strategic idea by 4 ambitious partners. It is reality in the making. Construction of the assembly and command ship began in December of 1995 by longtime ship designer and builder Kvarner Maritime of Norway. The ship serves as the launch vehicle integration and test facility as well as a command ship. And it might also be thought of as a floating hotel, as it's also home to 240 launch team members. In late 1996, it was fitted for mission control equipment while in St. Petersburg, Russia, and steamed into the Sea Launch home port in June of 1998. The seafaring launch platform, appropriately called the Odyssey, originally was an oil drilling platform used in the unforgiving North Sea. Today, it has special equipment on board that makes it a self-sufficient floating launch complex, complete with an environmentally controlled hangar for the launch vehicle, an erector system for positioning the rocket vertically, thrusters to maneuver the platform into its proper position for launch, and a remote command system. The Odyssey arrived at the Port of Long Beach in October of 1998. The Sea Launch home port, located in Long Beach, California, was designed and built especially for sea launch by Boeing and provides unrestricted access to the launch site. In addition, it's conveniently located near major U.S. satellite manufacturers. Its state-of-the-art payload processing facilities offer dedicated spacecraft fueling cells and an encapsulation cell. It will be used for more than a dozen satellites now scheduled for future sea launches. The home port also provides docking and provisioning for the assembly and command ship and the launch platform. Sea Launch uses a 3-stage rocket, which is a unique combination of proven hardware. The first 2 stages are derived from a Ukrainian Zenit rocket, which is one of the most automated launch vehicles in the world. The Sea Launch 3rd stage, a Russian-produced Block DMSL, is a modification of an existing design and has a long and successful history as the upper stage of the Proton launch vehicle. The new 4-meter payload fairing takes advantage of Boeing's extensive experience and facilities for composite production. While the Sea Launch rocket takes advantage of proven technology, its new features provide even greater efficiency. Fueling system modifications, upgrades to all flight computers, and an extensive quality assurance program enhance Sea Launch operations.
There were really no technical difficulties that we had to overcome because we were manufacturing pretty much the same rocket as before. The difficulties that we did have to overcome were due to the fact that Russia and the Ukraine were now separate countries, and we had to rebuild and restore those ties and relationships.
Far beyond the shores of the Sea Launch home port, out where few sport or commercial fishermen venture, is a place where history will be made. The Pacific Ocean, with its promise of fair winds and gentle swells, is destined to become the commercial space launch site of the future. With Sea Launch, full steam ahead.
I can't tell you how much I thank the Sea Launch employees. There's been 10 to 15,000 people working on Sea Launch under all kinds of stressful conditions, weather, being away from their family, that's come together to represent the achievement that we're witnessing today. So from the bottom of my heart, all I can say is thank you very much.
Well, first of all, I would like to tell you guys that there is a wonderful lady here named Amy, promising that there will be more and more successful launches for us all. And I would like to promise Sea Launch that we won't let anyone down, and we will work hard, and we will continue to supply the best possible rocket. So let's all work hard together. Good luck.
Сказать им большое спасибо за самоотверженный труд.
I want to thank you all for all of your hard work. I want you all to continue your work with precision and quality as you have in the past. Be proud of the immense heritage of your company, which is a premier designer of missiles and launch vehicles.
I feel that all of them has done a very good job. I know that a lot of people has worked hard for many years, and I hope we can all share the happiness of a successful first launch.
Дорогие друзья, дорогие коллеги, я очень благодарен.
My dear friends, my dear colleagues, I'm very grateful and very proud of everything that you have created with your own hands and with your intelligence and knowledge. Thank you.
Рад и горд, что работаю вместе с вами.
Я хотел бы выразить огромное спасибо всем, кого я.
I would like to express my deep gratitude to all of the people who worked on this project, to my colleagues in Russia, and to all of my American colleagues and to their families.
When this beautiful rocket flies from our platform, and it flies well, and it reaches orbit, and it satisfies the conditions which we are seeking, all of us will feel like we are receiving the biggest reward for the job, for that difficult job well done. And again, I want to thank you for your dedication, and thank you for what you have done.